Hi guys, today we are going to see question number 29 of GATE 2020 of mechanical paper 1. So the question is you're given a system like this where the properties of the system is given, that is 2 kg mass and the geometric properties and its initial velocity. Okay, and this is an elastic cord and its stiffness is also given to be 5 newton per meter. So now the cord is hinged at this point and the block is given a velocity of 1.5 meter per second perpendicular to the cord. That means the velocity is given in this direction. So the final question is, what is the magnitude of velocity in meter per second of the block at the instant the cord is stretched by zero point 0.4 meter? And you have four options. So before going into the problem, so this problem belongs to typically energy conservation problem. So you can check out concepts relating to these questions in NPTEL lecture Engineering Mechanics by Professor U.S. Dikshit and G. Sharavanakumar. Um, so let's go into the problem. Before going into the problem, you should know something about the springs. That is, the potential energy of the spring is given by half kx square. That is, if you have a spring which is initially of some length and now you stretch it by x distance by force F, and then this particular potential energy of the spring is given by half kx square. So now coming to the problem, let me draw this thing. So initially I have a block like this, okay, and it is fixed at one point. Let's say it is fixed at one point. So now what is happening? This particular block of mass m is being given some velocity. Let's say v1, initial velocity. So as this moves in this direction, let's say it reaches some point 2 with the velocity 2. So this is your string. So now what happens is this string will get elongated. So let me just draw this. So let me use a different color to show something. Yeah, so initially you had some length, right? So now you will have some different length. So let's say that this much part of the cord or string is getting elongated. So let's represent this particular elongation as delta. So this is your elongation of the string or core. Okay, so now what is happening here? So your mass was initially at this position. You had some kinetic energy, right? It is going to some new position. Let's say now you will have some kinetic energy at this point. Now what happened between this is this particular string is actually pulling your mass which was here. It is actually pulling it back, right, while this wants to go forward. So that means some energy is being spent on actually pulling it back. Okay, so your kinetic energy, so next state your kinetic energy is reduced as compared to this, because this is being this much is being dissipated or spent for pulling it back. So now what is this energy? This is the potential energy of this particular string or cord, okay, which is same as a spring problem. Okay, so you can write as uh, your kinetic energy at state 1 is equal to your potential energy of the cord plus your kinetic energy at state 2, right? So let me just zoom out a bit. Yeah, so now you can write this as half m v1 square is equal to half k delta square plus half m v2 square. Now we know that m is equal to 2 kg. You have v1 is equal to 1.5 meter per second, and you have your stiffness to be 5 Newton per meter. Your stretch is given 0.4 meter. Let me just verify that. Yeah, you can see here these are the values being given, right? So now I have to find what is the velocity, that is v2. I need to find what is v2. v2 is the velocity when my stretch is 0.4 meter. So if I use these values into this equation, I will get v2 to be roughly equal to 1.36 meter per second. So this is your answer. Please note all these values are being given, so you just need to find only v2 from this equation. That's it. So now let's check our answer. So our final answer, which is 1.36, that is our option C. So the option C, 1.36, is our answer. I hope everybody understood this problem. So here one thing to note is the main principle behind this problem, main concept is the conservation of energy. So please check it out. Thank you.